So now begins Chapter 10, Square and Square Roots. So perfect squares. You may or may not have heard this term before, but a perfect square is the result of a number. So a perfect square is the result of a number that is multiplied by itself twice. So here's the first 20 of them. So 1 times 1 is 1. So that means 1 is a perfect square because it's the result of the same number being multiplied by itself. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. So everything I've written so far in purple, those are perfect squares because they're the result of a number being multiplied by itself. 9 is the result of 3 times 3. So we'll just keep filling these in. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. Now we'll do 11 through 20. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. 16 times 16 is 256. 17 times 17 is 289. 18 times 18 is 324. 19 times 19 is 361. And 20 times 20 is 400. All right, that's a lot of numbers. Why would I bother going through 20 of them? Well, for our math class, you really just need to have in your memory the perfect squares through 144. I may change my mind, so if in class I say like through 15, or I might say 1 through 12 and 15, I'll make sure I inform you exactly in class, but I'm confident I will want you to, without a calculator, be able to tell me the square root, which we'll talk about in a second, of any one of these on 1 through 144. So you should be so familiar with these that you know, 36, that's a perfect square. That's just 6 squared. 81, that's a perfect squared. That's 9 squared. 121, yeah, I already know that number. It's a perfect square. It's 11 times 11. So make sure you are very familiar with these numbers and what they are for at least 1 through 144. So those are the squares, or perfect squares. Now let's talk about square roots. A square root is a number that produces a specified quantity when multiplied by itself. The symbol, the square root of x, which this in general is called a radical sign. We're not doing anything other than a square root right now, but there are other kinds of roots other than square roots. You'll learn those later. It tells you to take the square root of the number. So what the square root is saying, or asking you to figure out, is what number, when multiplied by itself, will give you the number found under the radical sign. So if they say, what's the square root of 16? You can say, okay, so what number times itself equals 16? And if you're familiar with these numbers up here, you should know, 16 is a result of 4 times 4. So that means since 4 squared, or 4 times 4 is 16, the square root of 16 is 4. So square roots are really just doing the opposite of squaring something. You see how if we square 4, we get 16. If we take the square root of 16, we get 4. So they're called inverse operations. Just like if I add 2 to 4 and get 6, then I could subtract 2 from 6 and get back to 4. So adding and subtracting are inverse operations, just like multiplying and dividing are. And then squared and square roots are inverses of each other. Okay, so let's practice this. So you can refer to the table up above if you need to, but eventually you'll need to at least know 1 through 144 without even looking at a table or your calculator. Square root of 25, that's 5. Because 5 times 5 is 25. Square root of 81 is 9. Because 9 times 9 is 81. Square root of 196 is 14. Because 14 times 14 is 196. So this is the number, when you multiply by itself, would give you the number underneath the radical, underneath the square root. So what times itself would equal 400? Well, that'd be 20, because 20 times 20 is 400. Okay, now notice, they may sometimes put a sign out front. You'll have to be later in math before you know why this is going to matter, having these signs out front. But for now, you just need to know, pay attention, and if they're there, keep them. So I already know my answer is going to have a negative in front, because that negative right there. So what times itself equals 36? Well, that'd be 6. So this time, this sign means plus or minus. It's really saying there could be two answers. It could be the positive square root of 121 or the negative square root of 121. And for both of those, it's 11. Okay, for 7, we have a negative sign, so we have to have a negative in our answer. And the square root of 49 is 7. Because 7 times 7 equals 49. Now, one quick thing I want to mention. You can take, or at least a calculator can take the square root of any number. Well, any positive number. But it's only these perfect squares that will come out to a whole number. So you can take the square root of 7, but it doesn't come out to a whole number. It's going to be 2 point something. I don't know what it is off the top of my head, but so it's not that you can only take the square root of these numbers, but it's only these numbers that when you take their square root, you get a whole number, an integer, instead of some crazy decimals. Oh, in fact, look, seems I was anticipating myself. But sadly, not all numbers are perfect squares. Aww. So how can we take the square root of a number if it's not a perfect square? There are two ways we can do it. So one is to find an estimate. So determine which two numbers determine the two perfect squares the given number is between. And honestly, I think this will take you a time or two before it makes sense, but I think if you just follow the pattern, you'll see what's going on. Okay? So for the square root of 33, that's not a perfect square. Darn. But if we think about what's the perfect square that's below it? The closest one would be 25. The one that's right above it, let me fill in, I'll go ahead and do that. So it's 33 is between 25 and 36. Now, 25, its square root is 5. 36, its square root is 6. So that tells us that the square root of 33 must be between 5 and 6. So we know the answer to the square root of 33 is somewhere between 5 and 6. It's not as small as 5, not as big as 6, but somewhere in between. So our next step is determine which of the perfect squares it is closer to. So for example, and don't overcomplicate this, is 33 closer to 25? Or is 33 closer to 36? Well, hopefully it's clear. 33 is closer to 36. They're only 3 apart, while these two are 8 apart. So since it's closer to the square root of 36, we'll use its square root, 6, as our integer estimate. So since 33 is closer to 36 than it is to 25, so the best integer estimate, so we are estimating to a whole number, an integer. Our best integer estimate is 6. Okay, So on this one, 129, we got to think, okay, what are the perfect squares closest to that? Well, 121 would be one of them. I'm going to put the negative out front here, just so we remember it. And then the one above it would be 144. Okay, so 129 is just 8 away from 121, but it's 15 away from 144. So it is closer to the 121. So whatever the square root of 121 is, we're going to say that is our estimate for the square root of 129. Okay, 67. Below it, we'd have 64. Above it, we'd have 81. So it is closer to the 64, only 3 away versus 14 away. So the square root of 64 is 8. So 8 will be our estimate for the square root of 67. Now, this is what I might ask you to do without a calculator, is finding the estimate. But you can also find the exact answer using your calculator. So get your calculator out so you can see exactly what's going on. Give me just a second. I'm going to get a calculator so you can see it in action. Okay. So we do need to put plus or minus in front of our answer for this one. But we don't know the square root of 40 because it's not a perfect square. So if you look, sorry if the light's doing funny things. If you look right above x squared, there's a square root sign. Now the way you make the calculator do the things above the buttons is by using the second button. So I will type second and then hit the x squared button because I really want the square root that's above it. So I've got the square root, so I hit second, square root, the number right by 7, and I type in the number 40. You don't have to close the parentheses, but you can if you want to. And you get 6.3245532. We want to round it to the nearest tenth is what it says. So that just means 1 decimal place. So we look, all right, there's the 3. I look past that. 2 is not 5 or bigger, so I don't round this up. So I make this 6.3. Now I'll do the same thing with 14. So I hit second, then I hit the square root, plug in 14, hit enter. Okay, so I have 3.7. If I look 1 past that, 4 is not 5 or bigger, so I don't have to round that up. So the answer is 3.7.